This week, I'm going to talk about multivariate analysis. I just want to remind you we're using multiple indicator cluster survey data for the analysis of this course, and we are trying to use this data to convert into a manuscript. So this week, the focus will be on logistic regression and how to understand the conceptual terminologies and other things behind it, interpreting the results both in the coefficients and odds ratios. So that's going to be discussed. And this week, the recording will be in two parts. First is more focused on the conceptual, and the second part will be I'm going to talk about using a software SPSS to show you those how to calculate the the odd ratios and other things by using binary logistic regression in SPSS. So first we need to be understand the terminology, what we use. So regression is a statistical method used to examine the relationship between variables. So we try to be predict outcomes, for example, income based on the education or some regions. And also we used to understand the relationship between the variables. For example, does income affect health? So instead of just showing association, regression quantify the impact of wealth and area on access to improved water sources. If you recall our last discussions regarding the access to improved water sources, where we did the cross-tabulation analysis. So that was we tried to show the association between the dependent and independent variables, and that case was the wealth and area. And regression is going to be beyond to quantify the impact of those variables on access to improved water sources. So this is a basic concept on the regression. And generally, there are two kinds of regressions we mostly use, but there are a number of regressions, but I'm going to be just give you the brief idea. So one we call the logistic based on the outcome or dependent variables. So nature of the dependent variable, if it's a binary, in other words, yes or no, or 0 and 1. So that most probably we choose the logistic regression to understand and to quantify the impact of independent variables on the dependent variables. But there is another very popular is the linear regression. So when we use when the dependent variable is a continuous variable. So it's not categories, not like like yes or no in kind of two category dichotomous, or we have more than two categories like wealth index. There are five categories. So it's not categorical. It's like a continuous variable. So we have a literacy rate. So it could be any number, and income could be any level number. So it's actual income level numbers or actual literacy rate at certain geographic levels. Those kind of situations we will like to be see the linear regression analysis in that situation. Okay, so our focus will be on the logistic regression, but I just want to give you a little bit overview how those two things are slightly different from each other. So linear regression, uh, take a outcome indicator or dependent variable as a continuous, and whereas the binary is in the case of logistic regression. And if you look at the equation, the model, we have y equal to we like the one have a dependent variable and the coefficient of the dependent variables. Here we use the probability, log of the probability equal to, and then the coefficients of your independent variables and their coefficients. So in other words, we predicting, for example, predicting water bill based on household income. So this is a kind of a linear situation where we can use this regression, and if we try to predict access to improved water, and we have, yeah, water is yes or no, that is the example which we could describe it. So how to interpret this? A change in y per unit. So change in y per unit, increase in x. So change in y per unit, it depending on increase in the x. So the same thing is change in log odds per unit, increase in x. So this is a kind of relationship they have between them. So change in the x will be like going to be a fact on the y, your outcome indicator in both cases. So like in the regression, it's logically the same process, but it's the nature of the dependent variables, how you treat them, they make them differently estimate or calculate them. So as I earlier mentioned, in this course, we are talking about logistic regression based on the nature of the dependent variable. So most of the variables based on the mix report and data sets are in like categorical, or particularly, or we can convert them into the binary case as well. So logistic regression, in other words, a type of regression analysis used for predicting the outcome of a categorical dependent variable. So a logistic regression model estimates the probability of an event. And in case of vaccination, so a child is vaccinated, yes or no, our household has access to improved water sources, yes or no. This is a kind of situation which is that event, the probability of that event is basically is calculated or estimated by using this. So there are key terminologies and the component which I'm going to be discussed, where you will be see how the different stages are in running the logistic regression. So all these things will be um, calculated, but when we use the software, we don't need to do any calculations. So I just want to give you a conceptually like how all the calculation or simple math is behind it. Okay, so we are going to be talk about uh, different things like odds, log odds, odds ratios, and regression, logistic regression. Okay, so before going to discuss about these different terminologies, let's have an overview of the cross tabulations what we did last week, where we took two variables, so area and wealth index quintile. Area has two categories and wealth has a five categories. And then the whole number of households are divided within those categories and by the have access to the improved water sources, yes or no. So you can see those percentage of household within that each category that's calculated. So this is the concept which I'm trying to be, this is the data I'm going to use to build that concept, how we will do that. So cross tabulation, just want to be remind you, provide a frequency count of the two categorical variables. So this is the two variables we have, and the chi-square is a confirmation whether this association is significant or not. So this is the kind of things we do that. So now keep this example in mind, and we will see how we will apply that one in the next those terminologies. Okay, so first we will talk about the odds. So odd represent the ratio of the probability of an event happening to the probability of it not happening. So this is the basically, if you look the formula, P is the probability and 1 minus P is the probability not happening. So this is the kind of equation they are using to determine the probability of an event occurring or happening. And example, if we take the example from the previous data sets where we have a total number of households with access to the improved water sources, and versus divided by the total number of households. So we have about 0.859. This is the ratio between them, and if we calculate the odds, so this is a p-value probability. In other words, so p will be taking in the p divided by 1 by p. So this is a value. You can see the calculation will be 6.1. So this 6.1 is the odd. So in other words, the odds of having access to improved water sources are one is 6 to 1. So in other words, is every 6.1 households with access, and one household does not have access to improved water sources. So this is the kind of things you can see how you see the odds. So log odds is simply just taking the log of that odd value, and that will give you approximately 1.8. So this is the interpretation is basic. If you look at the log odds value of 1.8 means a high likelihood of having access to improved water sources. So these two terminologies, you can see they are depending on each other. And if you look on this example, so first we calculate the probability. It's just a simple dividing yes over total number. And this is happening in all those categories we have in both variables. So once we calculate the probability, now you know the next formula is where you use odds. So probability p over 1 minus p. So this is the outcome when you put those values in the formula. So you will get the odds of this one. And after calculating the odds, and then you can apply the log, take the log of those odd values. So now you will get that information, which is the log odds. So those kind of things you can see how we simple mathematics can to produce this kind of information for you. Okay, so now next thing is which is called odd ratios. That's the main thing when we will see the SPSS results. We will get the odd ratios. So they have two different kind of odd ratios. So first, today we are in this lecture, we are going to talk about the odd ratio, but in the next class or lecture, we will discuss about the adjusted odd ratio, which is the actual number which we normally report when we are running some binary logistic regression analysis. So what is the odd ratios? Is a simple is an odd ratio compares the odds of an event happening in one group to the odds of the same event happening in another group. So it's basically, if you simply it's a dividing the two group odds of some event happening in group one and by the group two. So now the outcome could be the three different possibilities. So this odd ratio could be, in some cases, could be equal to 1. So it means there is no difference between the two groups. But in case of odd ratio is greater than 1, so the event is more likely in group 1. And if the less than 1, so in other way, is less likely in group 1. So this means the odds of having access to improved water are 4.6 times higher in urban households compared to rural households. So this is a kind of, if you take those values, so let's see those are the ratios we have. So we calculate apply those odds and then use the odd ratio. So basically it depending which category you want to set as a reference. So in this case, urban is set as a reference, which means it has a 1 value. So now we have these two groups, urban and rural. So we will divide 4.6 divided by 25. So we will get 0.018. So when we compare 1 versus 0.18, so this will be the comparison we see. So have like less chances, less likely access to improve water sources in terms of a rural area as compared to water, because as compared to urban, because a rural odd ratio is less than 1. The same thing is if you look at in the wealth quantile wealth index. So we set the lowest and poorest class as a reference, which means again we set as a one. So now the calculation will be, so this group will be the denominator in all four cases. So we will take the value of 3.8 divided by 2, 8 divided by 2, 55.9 divided by 2. So this is the way 2 will be using as a denominator in all cases when we calculate the ratio, and compare the odds of in other categories. So those odd ratios are basically telling you how many odds they have in term when we compare with respect to the poor's category. So this is the kind of basic concept which I'm going to try to give you before entering in SPSS. So most likely we are going to use the odd ratio, but not exactly the odd ratio. We will use the adjusted odd ratio, which normally try to be adjust the impact of one variable when we can estimate it when we are estimating the odd ratio for the other one. So it means we are controlling the confounding effects on those estimations. So we will discuss about that thing in the next video where you will learn more things. So this is all about this week. So as I mentioned, next week or just raw ratios, and then we will be using SPSS to estimate all these things.